Okay, this is the new movie that we'll use in order to continue our chapter 6, and this is the last slide from previous movie. Previous movie's point we were talking about types of random variables. We have discrete random variable, continuous random variable. Okay. The mean, variance, standard deviation for a probability distribution. Previous movie we were looking, you were watching what does it mean probability distribution and what characteristics of probability distribution that we need to understand or we need to remember. And now suppose that we have probability distribution and we want to find mean of probability distribution, and we want to find variance and standard deviation of a probability distribution. That's why in order to find mean, variance or standard deviation, we need to we need to get back the meaning of mean or the definition of mean, variance and standard deviation. That's why we call recall here. Recall means call it back. Okay, mean. The mean describes the central location of data. Okay, remember that this is from chapter 2, part 1, central tendency. So we use mean, median, mode. Mean at that time we have three types of mean: arithmetic mean, weighted mean, and geometric mean. But in this case we use arithmetic mean. So the mean describes the central location of data. Variance describes the spread in the data. Okay, so we in order to understand the central values of the data set, we use mean. In order to understand the variation values of the data set, we use variance and standard deviation. Okay, a probability distribution is summarized by its mean and variance. So when you have probability distribution and you want to summarize or you want to describe this probability, we need to find mean, we need to find variance of this probability distribution. The mean of probability distribution is called μ. This is μ. The standard deviation of probability distribution we call sigma, or sigma square is variance. Okay, this is not really the strange symbol. We already understood this one from previous chapters. The mean of a probability distribution μ. The mean of a probability distribution is a typical value used to represent the central location of a probability distribution. That's why if you want to find or understand the central location of a probability distribution, you need to find mean of that probability distribution. The mean of a probability distribution is also referred as expected value that we call EX, expected value. That's why when you say expected value of probability distribution, this is mean of probability distribution. So mean of a probability distribution is the same thing as expected value of a probability distribution. Okay, so but normally they just saying expected values of a probability distribution rather saying mean. This is a formula in order to find mean or expected value of a probability distribution. That's why in order to find mean, first you need to have outcome. Remember that probability distribution, you have outcome column and then you have probabilities column. That's why this is X. H is 1, 2, 3, some say. This is Px. X1, Px1, X2, Px2. So in order to find mean of a probability distribution or expected values of a probability distribution, you need to have outcome. It means you have to have probability distribution. That's why you have outcome. You have probability of each outcome. Just take multiplication or just take outcome multiplied by its probability and add them together. This is mean. Okay, look so easy. When you have probability distribution, you have outcome list and you have probability list. Okay, just take outcome 1 multiplied by probabilities of outcome 1, outcome 2 multiplied by probabilities of outcome 2, outcome 3 multiplied by probabilities of outcome 3, outcome 4 multiplied by probability of outcome 4. If you have 4, add them together. This is we call expected value or mean of a probability distribution that you have. Okay, so outcome multiplied by its probability, add them together, is expected value or mean of a probability distribution. Whereas x is a random variable, x1, x2, x3, x4, x5. Px is the probability of the possible values of a random variable x. Variance of a probability distribution. The variance of a probability distribution represents the amount of spread or deviation in a probability distribution. So the variance of a probability distribution represents or shows us or displays the amount of spread or the amount of deviation in the probability distribution. In order to find variance, you need just actually, if you have probability distribution, you have outcome, you have probability of each outcome. And from previous slide, you have mui. Mui is it? What is it? Mui is mean or expected value. That's why variance is about deviation. What does mean deviation? Is minus. Outcome minus mean and take square. Okay, outcome minus mean and take square. Then multiply by Px. Okay, for example, x1 Px1, x2 Px2, x3 Px3, x4 Px4, and then finally add them together. This is we call variance. Okay, so again, you need to have probability distribution. When you have a probability distribution, you can find outcome and probabilities of its outcome, and then you need to find mean from previous slide. And this one you need to take a deviation, take square and multiply by Px. x1 Px1, x2 Px2, x3 Px3, x4 Px4, and then add them together. This is we call variance. Okay, so this is a step that you need to do this one, but I just take in advance. First, you need to subtract here the mean from each value of outcome, and then take square, Okay, first subtract and take square. 2 multiply by its probability. 3 sum together, add them together. Okay, that's why this is we call variance of a probability distribution. If you know variance, in order to find standard deviation, just take a square root. Okay, just take a square root. That's why we call standard deviation of a probability distribution. Okay, to study mean, variance, standard deviation of a probability distribution, we study by taking example. Example: John, this is his full name, but I just call John. John sells new cars of Ford new car. Okay, John is a seller of Ford car. This one. John usually sells the largest number of cars on Saturday. So every Saturday he noticed that he could sell more car. Every Saturday compared with the other day, Monday, Tuesday, Wednesday, Thursday, Friday, and Sunday. Saturday is the big sale. He could sell more car on Saturday. This is based on his experience. He has developed the following probability distribution for the number of cars he expects to sell on a particular Saturday in the future. Any Saturday in the future, he wants to check how many cars that he could sell in average. That's why he need to develop, based on his experience, he need to develop a probability distribution. This one. This is number of cars sold by John on only Saturday, not in a week. This is only on Saturday. Typically Saturday so far. Only Saturday. That's why this is the chance of John could sell number of cars on Saturday. 0 car. Only 0.10 or only 10% of chance that John sell nothing on any Saturday. 1 car sold on Saturday, 20%. 2 cars sold on any Saturday, 30%. 3 cars sold on any Saturday, 0.3, 30. 4 cars sold on any Saturday, 0.10. So together is 1. Okay, this is we call probability distribution. This is we call outcome. This is we call its probability. This could be quantitative. Okay, quantitative, and moreover discrete quantitative, because car cannot be 0.1 car, 0.5 car, only no car, 1 car, 2 car, 3 car, 4 car, 5 car, something like this. That's why this is quantitative and moreover discrete quantitative probability distribution. This is we call discrete probability distribution table. So what types of probability, what type of distribution is this? What do we call here? On a particular or typical Saturday in the future. On a future typical Saturday, how many cars does or will John expect to sell? What is the variance standard deviation of the probability distribution of cars sold here? Okay, so we have 3 questions based on this probability distribution. Okay, so the probability distribution for number of car, it should be, okay, this is the answer. This is the answer. What types of this distribution is this? The probability distribution for numbers of car. Mean of probability distribution. This is the second question. Okay, in order to find mean, remember that in order to find mean, you need to have outcome. You need to have probability of its outcome, and then you can multiply them together. Finally, you add all multiplication. You add all products of this together. You add all products of x and px together. This is we call expected values or mean of a probability distribution. Okay, so when to do is 2.10. What does it mean 2.10? Mu equal 2.10 indicates, show that, presents that over a large number of Saturday in the future, because we don't know how many Saturday in the future that John stay here for as a sellers. That's why just over large number of Saturday in the future. John will expect to sell 2.1 cars a day on particular Saturday in the future. 2.1 car. Maybe you can ask me, car cannot be 2.1. The number of car cannot be 2.1, 2.3, 2.5 or 0.1. Yes, actually number of car is discrete, cannot be continuous. But this is average. This is not actual number. This is average. Okay, average can be. What happened? Okay, 3. Variance. 3. Variance of a probability distribution for numbers of cars sold. That's why in order, based on formula, in order to find the variance of probability distribution, you need to have mu, and then you need to take deviation or difference or subtract outcome minus mu, take square and multiply by px. If you have how many x, if you have 4x, add all this value together, so we got variance. Okay, so just do it. Okay, so this is a probability distribution table. This is we call deviation between its outcome to the mean, to the expected value, and then take square. So the first is here, and then next take square, and then multiply together, multiply this one to px, finally add them together. Okay, this is we call variance. So again, when you know mu, you need to take a deviation outcome to the mean, and then take square, and after that multiply this result to the px and add the result together, we call variance. When you know variance, you can find standard deviation. Standard deviation is just square root of variance, 1.136. Okay, what does it mean 1.136 standard deviation? It means that, for example, on typical Saturday in the future, John expects to sell in average 2.1 car. This is average car sold, average car John expects to sell in any Saturday in the future. Okay, in the future. But some Saturday in the future, John could sell less than average. Some Saturday in the future, John can sell more than average. How did we know how many less than? How many less than average? How many more than average? By comparing, by taking standard deviation. That's why less than average by 1.136. Some Saturday, John could sell, or John will expect to sell more than average by how many more than average? By 1.133. Why is it that one? This is from standard deviation. Okay, that's why in average, John expect to sell 2.1 car in the future for any Saturday, but some Saturday he expect to sell less than average by 1.36. That's why 1036. And let's say 1 car. John, in the future, he expects to sell less. The less car sold is 1. How about car sold? 3. 3.236. Let's say 3. Okay, because car cannot be point something. So this is normally on any typical Saturday in the future, John expects to sell 2 cars. But some Saturday in future, some typical Saturday in future, John expects sell less than average by this amount, so only 1 car sold. But some Saturday in future, John expects to sell more than average by 3. Okay, so in average 2 cars sold or 2 car will sell less than at least John expects to sell 1 car. At most John expects to sell 3 cars on any typical Saturday in the future. Okay, this is the meaning of standard deviation. Okay, this is practice review 6.2 on page 193. Okay, this is for your own practice in order to check whether you can do this or not, you can find solution on this or not. If you can find solution with this correctly, it means that you understood what you have learned or what you have watched so far. And this is an exercise for your homework on page 193 to 95. Okay, we can go to textbook together. Okay, this is page 193. This is review 6.2, not 6.2. Okay, the Pizza Palace offers 3 sizes of cola. Cola that means drink: small, medium, large. To go with its pizza. Pizza for eating, cola for drinking. Colas are sold for 80 cents, 90 cents, and 120 cents. Not $1.20 respectively. Okay, I will show you what does it mean respectively. Respectively, that means order. What does it mean order? You can see there are 3 colas: small, medium, large. So this is order. Small, medium, large is order. And also the price: 80, 90, $1.20. This is also order. That's why when we use respectively, you can see this is 3 order side, 3 side order. This is 3 price also order. That's why we use respectively, that means in order. What does it mean in order? The first side, the first price. Second side, second price. The third side, the third price. That's why we have 3 sides. We also have 3 price in order. That's why this is the meaning of respectively. So normally when you read economic article or paper or business articles or papers, normally authors or writers always use this phrase. Okay, so respectively we have 3 sides. We also have 3 prices. That's why the first side, the first price; second side, second price; the third side, the third price. This is order. Okay, again, the Pizza Palace offers 3 sizes of cola: small, medium, large. To go with its pizza. The colas are sold for 80 cents, 90 cents, and $1.20 respectively. 30% of the orders are small. 50% of the order are medium. 20% of the order are large size. Okay, this is information. Organize the size of colas and probabilities of sale into a probability distribution. So this is not question, but they ask you to do. Organize. This is not a question. A question here. Organize the size of the colas and probability for a sale into a probability distribution. Okay, again, this is not a question, but they ask, they force you to do it. This is a question. These are the questions. A, B, C. Is this a discrete probability distribution? Indicate yes, why, or explain. If it is yes, why? If it is no, why not? Okay. B. Compute the mean amount charged for a cola. Compute the mean amount of money charged for a cola drink. C. What is the variance in the amount of money charged for a cola and standard deviation? Okay. So actually there are 3 questions asking, but this is not question. They also ask you to do. Okay. In order to answer this one, you need to organize into frequency distribution. Okay, this is a review 6.2. Now we're going to exercise. Exercise as homework for next week. Exercise number 2 on page 193. Exercise number 6 on page 194. And exercise number 8 on page 195. Okay, so this is exercise numbers as a homework for you to submit next week. Okay, so I stop by this and turn this movie to you to watch, to study, to practice in order to get more understanding.